Welcome to Kelp. In this tutorial, we're going to build an automation for enriching leads and generating proposals for SEO agency services. This is a traditional workflow where every step is predefined and must be executed in a specific order for each input. You'll see that this type of automation is the right solution for a wide range of use cases. This is a simplified version of one of our recent use cases. An SEO agency wanted to build an automated lead qualification and outreach pipeline. The process begins with a pre-selected list of local business leads exported from Apollo in CSV format. We then iterate through each lead, generating an SEO report for website URL using Google PageSpeed Insights API. Next, we analyze the report to qualify leads for outreach. For qualified leads, we use AI combined with all collected data to write personalized emails. Finally, we format the results back into a CSV file, ready for export to Lemlist or your preferred email campaign tool. Okay, with a little bit of Kelp, we'll put it together step by step. To obtain the data, we'll use a form to upload a list of raw leads from a file. At a minimum, each lead record should contain a URL, first and last name, company name, and email address. I'll start by adding a form widget. Use the Insert Component button on the top bar or right-click anywhere on the canvas to open the components library. Look up the form widget and click Place Instance. The form widget requires a form specification in JSON schema form format. I'll add a JSON constant for the spec and connect it to the JSON schema port. To edit it, select the component and press space to open the settings dialog. We just need one field for file upload. To preview a form, you can either open the widget's settings dialog on the View tab or expand it directly on the canvas. When submitted, the form widget will emit the file contents through its onSubmit port. We'll use the CSV parser component to convert this data to JSON. Kelp loves working with JSON. For the parser component to work properly, we need to ensure the input is in plain text. We'll apply a transformation function on the wire to convert the file into plain text. Press space on the selected wire and enter the following expression. Next, configure the parser to expect CSV input. Output the data as an array of objects and use the first row as column headers. Now we're ready to iterate through the leads and repeat the enrichment steps for each one. For this, we'll use a buffered iterator composite component, or simply a composite. Composites are published extensions to the standard Kelp components library. You can find them in the extension section of the library. Place the buffered iterator and connect it to the parser output. We'll create a group and place the item processing flow inside it. We'll send items as input for processing. Then we'll forward each output to the keep port to accumulate the results. We'll dive into the implementation details shortly, but first let's handle the results so we can test the flow. We split the resulting collection from the buffer port into two collections, one with qualified leads ready for further steps, and another containing unqualified leads and any errors that occurred during processing. For qualified leads, we'll add one additional step, converting them back to CSV format. We'll send each collection to a download component with a button, so you can download the results at any point, and to a table widget for review. Don't worry about the transformation details now. I'll return to them once we have processed the results. Let's add two more controls, a progress status composite to monitor the process, and a cancel button as a safety switch. You can cancel the iteration at any time by simply sending a reset signal to the input port. We're now ready to do a test run. As always, you can test the flow right from the canvas or place the widgets on the layout and run it from preview mode. If you copied the app from a template, all the links are below in the description, you should see something like this. Upload your test leads file and click Run Workflow. Since we haven't finished the processing flow yet, you should see all leads appear in the results table. So far, everything works as expected. Now double-click on the group we created for processing items from the iterator to drill down inside. This group receives an object containing properties for a single lead as input. We'll then return the same object with additional properties we've generated. We can use Combine by Component to help us collect all the parts of the output and emit it once we know we collected everything or when an error was caught along the way. Connect the input to the first port and rename it to lead. This will become a property name in the output object. The next step is generating a page speed report for the lead's URL. We'll use the Page Speed Insights composite for this purpose. Connect the group input to its URL port and add a transformation to extract the URL string from the input object. Adjust the settings as needed. For simplicity, we'll use a summarized text version of the output report. Connect the text port to the next port on the combine by component and rename it to report. If you need the full details, you can use the JSON output port instead. While the Page Speed Insights API can be used anonymously for free, it has usage limits. You'll need to request and use an API key if you plan to generate numerous reports daily. Next, we'll analyze the report with AI to automatically determine if the web page performance falls below our thresholds. For this, we'll use the Ask AI composite, a simple AI component that generates LLM responses based on text input. This component is ideal since all the information needed to qualify a page is contained in the text report summary. Add the Ask AI component and connect it to the page speed component's text output and to another input on the combine by component. In the settings, select the Open Router integration, specify your preferred model, enter your prompt, and enable the JSON response format to ensure the model returns structured data. It will help us to triage leads in the next step. Let's examine the prompt to understand how this works. This prompt defines how to pass scores in the report, then applies clear qualification rules to decide if the page needs SEO services. The core logic is driven by thresholds, which can be adjusted to fit your standards. The output is restricted to a specific format to be used in the next steps. After qualifying the lead, we'll route it based on the qualified parameter value. Add a conditional router composite, connect it to the response output, and set the expression to qualified in the settings. This router will direct leads with a qualified parameter value of true to its true output port, and all other leads to the false port. Next, we'll generate a personalized email for each qualified lead. We'll use another Ask AI composite for this step. To create an effective email, we need both the initial lead details and our evaluation results. We'll set up another combine by component to collect these data points on lead and eval ports respectively. We'll use the true output from the conditional router as the flush trigger. Then we'll connect the object output from this new combine by component to a new Ask AI composite. Let's examine this prompt as well. First, the prompt defines what information we're working with. Then it tells the AI to pull out the most important parts: opportunity level, main issues, quick wins, and key metrics. Next, it builds the email structure with a subject line, opening statement, key findings, value proposition, call to action, and signature. It also sets the right tone and gives an example of what the output should look like. Finally, it makes sure everything comes back as JSON so we can easily use it in the next steps. The email was the final piece of content we needed to collect for qualified leads. We'll send it to the email port on the combine by component and use it to trigger the flush of everything we've collected. To ensure that we call flush only after the email event arrives, we'll use a fork component that guarantees the correct order of events on its outputs. I think we're done. Wait. In an ideal world, this would be sufficient, but in reality, exceptions happen. We need to handle all potential situations where things might deviate from our desired path. One effective approach is to collect all errors along the way and save them as an additional property in the final output object. This allows us to sort them out later during export or when presenting results on the UI. I'll funnel all error outputs into a single stream. When an error occurs in a component, it emits an event only from its error port, not from its expected output port. This error handling pattern is supported by all Kelp components. For leads flowing through the false port of the conditional router, we're handling unqualified leads rather than errors. We'll simply label them as not qualified and sync to the error stream as well. Finally, we'll save the error stream in the rejected port of the last combine by component and flush it. Now we're done here. Let's go back to the root level and fix the transformations we left earlier. We need to split our processed leads into two collections: qualified leads, ready for export to a CSV file, and everything else, which will include unqualified leads and errors. Let's define the transformation for the first collection. Since we connected to the buffer port of the buffered iterator component, we'll receive an array of currently processed leads every time a lead is processed. We need to add a filter for items inside the array. Our filter criteria is simple. Take any item for which the rejected property is not defined or null. Let's test it. Turn on the capture events switch on this transformation and run the workflow. Once a couple of leads have been processed, we can go back to that transformation and see what data we're actually getting through. As you can see, only the leads with the qualified property equal to true and an empty rejected property are getting through. All that's left to do is pick which properties you want to see in the exported CSV file. Update the transformation with the following expression to keep only the properties you want to see in the output. For the other collection, we invert the expression to filter for items where the rejected property is not null. Since we're not exporting errors to a CSV file, we can keep them as JSON objects with full details for further analysis. Instead, we'll add a transformation for the errors table to display a few key properties so we can monitor them while the workflow is running. Now let's run it again to see the final results. The requests to the Page Speed Insights API can take quite a long time, so I'll wait until all test leads are processed. Looks like it's finished. Let's download the results. Perfect, exactly what we expected. You can customize this workflow for many other scenarios. For example, you could enrich a list of companies with external data, or process a batch of PDF documents, or summarize a set of videos. You'll find a link in the description to fork this tutorial and start experimenting. If you need help bringing your ideas to life, reach out to us. We'd love to help. And don't forget to like, subscribe, and share your thoughts in the comments. Follow us for more helpful videos.